Search is never finished. That's one of the sad truths about this. You start with a certain level of quality and you try and improve it and you try and continue to improve it. You're never going to finish that task because the world changes. The sort of queries people use change. Content changes. New content arrives all the time. Let's give an example. A few years ago, we had a client who suddenly found lots of people were searching for personal protective equipment, masks, and we all know why that was. But the world had changed overnight. Suddenly, the most important queries had changed overnight. And suddenly the content that they needed to surface was particularly valuable to them, and that's something they needed to be able to sell very quickly. So we have a constant process of improvement of search quality, and that's what the train we need to get on. We're not going to be able to say it's going to be this much better by next week, but we need to be continuously improving and adjusting and creating a process where we can constantly measure and improve and iterate is really important.
What is a relevant search result?
So I think a relevant search result is very much a subjective thing. What's relevant to you may not be relevant to me. It very much depends on what task I'm carrying out, what my information need is. Am I just exploring? Am I browsing? Am I trying to buy something? Am I trying to find out some particular information? Or am I just asking a vague question to educate myself? And this makes it quite difficult for us to measure relevance, because if we ask a person, even two people who are both experts in the same area are going to disagree on the relevance of a particular result. This is a very common problem. And if we do it by some kind of more automatic means, for example, looking at results people click on, then people click on results for all kinds of reasons. They click on them because they're higher up the list, something we call position bias. But it's a hard thing to measure. But yeah, relevance is a hard thing to define. We can explain it ourselves. We can maybe explain our reasoning, but getting a consistent view of what is a relevant result is really hard.
Yeah. So maybe let's start there with the problem. What do you think are the most common things people get wrong when they assess search systems and try to improve?
It depends what we assess. One of the common things people look at is just processing speed. How quickly does my search result come back? And they may say a search result comes back quickly is more accurate or less accurate. It's a strange thing. We perceive the speed of how fast a computer responds as telling us something. Maybe a complex system shouldn't come back immediately. That's one thing you can measure, just the raw performance. And then you have various measures of what results have come back. We have traditional ones such as recall and precision. How many of the results you've got are actually relevant? How many of the possible relevant results have you been shown? And then we have to figure out, again, a way to measure them, to calculate some data to give us some number that says how good is search today? How good is my search engine performing? Is it giving my users useful results? There's two main ways to do that, and possibly a third. The first one is just to ask some people. So I'm going to find some people who know something about shoes. I'm building a shop that sells shoes. And I'm going to type in red shoes, and I'll ask these people, out of the results that have come back, how many of these are actually red shoes? Now, again, some of these people might disagree. They might think a red pair of sandals isn't a pair of red shoes. They may say a slightly purpley pair of shoes is actually red. So there's some problems getting humans to judge these things. But I'm going to get them to actually give me some numbers. Is this a great result? Is this a kind of middling result? Is this a terrible result? Is this not relevant at all? Collecting those numbers gives me something I can then measure. And I can give that for a particular query, say red shoes. I've now got a number to say how good is the results I'm coming back. So that's one way of doing it. And that has the problem that it's not very scalable. I've got humans in the loop. It's not the most exciting task to do, but it's a very common starting point for measuring search systems, is doing some kind of human-powered evaluation. The next way I can do it is by looking at what users do with my system. What do they click on? How do they interact with it? Did they buy this particular item, for example, or did they download a PDF based on this search result? And I can collect my clicks, and that's done with some kind of web analytics tool. The trouble is this is very noisy data. People click on things for all kinds of reasons. And it's often quite hard to figure out the connection between that first query and an actual action at the end that validates it. I search for something, I do research, I search for something else, I change my query, and eventually sometime in the future, I do some action to validate that. I download something or I buy something. How do I connect those actions together? How do I maintain causality all the way through? But it's, in theory, it's cheaper. We can just harvest the clicks off the web, do some data crunching, and we've got a load of data, and that tells us which results are relevant. And then the third way, which is the new way, is to get an AI to help. So we could actually get an LLM, for example, to judge the quality of search results. Now, this is fine, as long as we trust our LLM. And in theory, it's more scalable. We've not got real humans involved. We've got a computer. But the problem is we've also got to train my LLM on something. And for that, you need some kind of human backup. You can't just assume that an LLM that's trained, for example, on a generic case, knows anything about shoes or about resumes or about cooking. And our experts do, but the LLM may not know that well. So you've got to be careful how you do that. But it's showing increasing promise. So those are the three main ways we train, we measure search systems, the pros and cons of each.
Yep. I'm really curious. Like, I will probably ask a few questions on each one. In the human evaluation, do you use like a standard scale across different projects you've done, or you have advice on basically like 1, 2, 3, 4, 5, or is it really dependent on the use case?
It's dependent on the use case, but I think the important thing is if you pick a scale, you've got to stick to it, and you've also got to have some guidance for people using it. So again, a common scale is brilliant result, middling result, poor result, and awful result, absolutely irrelevant result. So a scale of 4, or you can do 1 to 10, or you can do just a binary. Is this relevant or is it not? But then if you have human judges, you then need to educate them on what you mean by these scales. So what is poor? What is fair? What is middling? And again, that's a subjective judgment and people will disagree. There are some ways you can sum these results, average across them, get some measure of what they call inter-rater reliability, some idea of how raters work. But yeah, the scale is really up to you. It depends on what you're trying to do and what you're going to do with the data eventually. If, for example, you're going to feed some kind of machine learning system, you may want the data, the judgment data conditioned in a certain way to feed that system. So that may influence your choice of scale, but it's entirely up to you. So I see 1 to 10, I see 1 to 4, I see binary 0 or 1.
And do you also ever collect comments from the actual user why the different results were not as well suited for the search or were suited for the search?
You can, yes. This does put more of a load on the user, but often to get some explanation as to why they rated something terribly badly. So for example, maybe useful, that may reveal other problems with your search system. For example, the result you showed them may not be, you may not have shown them enough. You may not have shown them a picture, for example, and they're asking, is this a relevant result? I need a picture of the book before I can tell you. I need a picture of the shoes. But it does make the evaluation task a little more onerous, but it can give you useful context. People do love to complain about search, and sometimes all you'll have is the complaints and the negative feedback. But when you're doing evaluation, you want both pros and cons. The trouble is people are less likely to write you a compliment than they are to complain. It's quite common for search teams just to have a litany of complaints they work through, and they become very reactive to those and just think we've got to make these people happy. But yeah, comments can be useful context, but they don't give you any kind of quantitative data, of course.
Yeah, I only think like always the human evaluation and especially the comments and the AI as a judge work quite well together because you can use the comments to actually feed the LLM and tell it what to look out for.
Possibly. I think to train an LLM, you need a lot of data. Possibly. I think that might be worth investigating. But generally, I think we need those. No, we need those hard judgments. And the text is just more decoration than useful context. And again, might inspire you to look at something else, but it's not necessarily going to give you any deep insight.
And more on the technical side, when you come into a project, in a new search project, and they already have a search system implemented, what are like the first few technical components you actually implement or have the team implement so you actually can start to even assess the search system and how well it works?
My first question to teams is, what do you know about how people interact with your system? Now, do you have complaints? Do you have a set of queries now just don't work? Do you have any quantitative data that you've measured? A lot of the teams we work with have never really measured search quality before. In fact, quite often I'll ask, how do you know if it's a good search result, and they'll say, well, we don't really, we have no way of assessing that. So that's my first question. What have you done before in terms of measurement? Pardon me. And then we're looking to what we can add to the system to start doing that measurement. We have an open source tool we built called Cupid, for example, which will sit on top of a search system and let you set up test queries in sets, what we call cases, and then run those queries on your search engine and then collect those judgments, and they can be used by people who are non-technical. So we might do that. And we might do it with as few as 50 queries, say. So I'll say, show me your query logs, show me what people are actually searching on your system. And we'll figure out a way to sample those queries and come up with, say, the first 50 we're going to test. Put those into our tool, make sure our tool's pointed at your search system or an offline version of it, say, with realistic data. Run the queries and get some numbers. And that gives us a starting point. Another way is to look at the query logs and begin to try and subdivide the queries. Some of the queries people are using may be informational, some may be very specific, some may be vague, some might be multi-word queries. Let's start dividing those up and thinking about each as a particular use case. For example, looking for a serial number shows a very specific need for a certain thing. And you can't just show someone loads of other things. They care about that item. Somebody typing in dress to wear to a prom is a very vague descriptive query. They're looking for advice. So let's subdivide those queries and then figure out where we can help in each area. We then need to think about prioritization. What are the most important queries for your business? If you make more money, for example, selling shoes, then perhaps we should fix the shoes queries first. But if you think it's more important to concentrate on this other area, we'll put it on that. But we need to think about the kind of business drivers behind this. Why have we come to help make your search engine better? How does your business connect to the search engine? What is the search system doing for you? And that's where we can prioritize and figure out where our areas of interest should be. The other very important thing is to look at the source data. No search system in the world can produce brilliant results from a garbage input. So what are you doing with that source data? Where does that come from? How is it controlled or regulated or processed, or what happens to it before it gets into the search index? And that data quality issue is a massive problem for search and also for pretty much any AI system as well. And it's something that's very much ignored, I think. We assume these machines can somehow produce beauty from nonsense. But they can't always, and the data quality is a huge problem. So that's something we look at very early on as well. The search engine itself, are you using an old version, a new version, what technology you're using, etc. That is a factor, but not as a bigger factor as you might think. Often it's the way you're doing search is way more important than the search technology you're using. Again, if you're feeding in garbage, no search engine in the world is going to be able to sort it out. If you're not measuring quality, how can you adjust the parameters to tune it? But just thinking you've got an old version, upgrading it's going to fix everything is generally not the case.
How do you start detecting the garbage? If you assume you have like terabytes of data, how do you start to go about that?
We can look at, again, the queries and what people are getting. An example, for example, is you might say, be looking for a specification document. I want to know this specification for this item that was manufactured in 1992. And then you do that search and you get back 20 results, all called specification version 2.1 final, no, absolutely final, copy final, approved version. And they're basically the same document. And that points very clearly to a problem with versioning, a problem with content. Or you might just get a totally irrelevant result when you're pretty sure there is a relevant item in there. Your content, you have this thing, but you just can't find it with search. Why not? And that might point to a problem with how you're conditioning the data before it gets into the search index. Are you picking up the right fields? You might see you can't retrieve a certain object type. For some reason, we're getting no PDFs in the search result. Why is that? Maybe we're not processing PDFs correctly. So those test searches give you some idea of what's coming in, where there might be a problem with content. When we dive in a bit finer, we figure out what's happening with the content before it gets to search. And there'll often be people who deal with editorial control of the content or deciding which items of content get into search. And they may be disconnected from the search team itself. They may produce beautiful web pages or beautiful content or documents, but they don't really understand what's needed for search. So they might, for example, put the wrong metadata in. the search engine picks up the metadata, it's in the wrong field, it's got repeated words in the wrong field, and this skews search results. So we need to make sure that the people controlling the content understand what we need as search people to make sure the content is surfaced.
And do you think that search systems improve one error at a time? So you're basically doing an error analysis. So you basically pick the most important error at the time, try to fix it, and hope that it doesn't destroy any of the other queries.
Search is never finished. That's one of the sad truths about this. You start with a certain level of quality and you try and improve it, and you try and continue to improve it. You're never going to finish that task because the world changes. The sort of queries people use change. Content changes. New content arrives all the time. Let's give an example. A few years ago, we had a client who suddenly found lots of people were searching for personal protective equipment, masks, and we all know why that was. But the world had changed overnight. Suddenly, the most important queries had changed overnight, and suddenly the content that they needed to surface was particularly valuable to them, and that's something they needed to be able to sell very quickly. So we have a constant process of improvement of search quality, and that's the train we need to get on. We're not going to be able to say it's going to be this much better by next week, but we need to be continuously improving and adjusting and creating a process where we can constantly measure and improve and iterate is really important. A lot of search teams are reactive. They are being complained at. They're being sent problems. They're being told on a Monday morning their boss searched for something on a Sunday that no one else has ever searched for because the boss searched for it. We've got to fix that today. They're in a constant panic mode. What we want to do is turn it into a more proactive situation where we have a constant measure of search quality. We have strategies to try and improve that. And we're consistently trying new experiments, new ways of adjusting our search engine to improve our search results, our metrics, and drive the business forward. We want to have a more sensible process for dealing with search improvement.
Before we move maybe into the constant measure, how do you get proactive, especially in tracking new groups or categories of queries that are suddenly coming in?
We need data. We need to be monitoring what people are doing. We need the support of analytics teams. We need to look at what's coming into the search engine and what people are doing, how user behavior is changing. Knowing what your user is doing with your website is obviously vital, and we put a lot of investment into that. People do this a lot on SEO, for example. SEO teams are often very focused on what are the queries, what are the things people are looking for that find our website. And they'll put a huge amount of effort into developing ads, for example, pay-per-click ads that respond to those particular search queries. But on the internal side, when we're looking at what a search engine does, we also need to be monitoring those queries on a constant basis. We need dashboards. We need visualizations to show, hang on, we've suddenly got loads of queries from this part of the world asking about this thing. What's that telling us? And there's a lot of intelligence in that information. We had a client who was selling sportswear, and they suddenly noticed that a particular basketball star in the US their name was coming up all the time in queries. Now, what had happened is this basketball star there was now some branded clothing associated with that name. Our client weren't selling it. But by spotting these queries, they then can ask themselves, should we start stocking it? So what people are searching for can inform you about the way the world is changing, and you need to be constantly looking at that. Another very common thing is looking for search queries that give 0 results. 0 results is a terrible place for a search engine to end up in, because if you type as a user, if you type in a word and back comes 0 results, what do? You assume something's broken. The thing doesn't exist. You go somewhere else. You go and use a competitor. A lot of people will just leave you there in that poor 0 results page. I'm sorry, we don't have any results for your query. I'll not help you out, take you anywhere, try spell correcting your query, suggest alternatives. Knowing which queries are giving 0 results gives you a really good place to start improving search. And we want to try and reduce that percentage of 0 results as much as we possibly can, because we want to make the user feel that they're being catered for. Yeah, there are various ways, but I think that intelligence about what users are doing is a vital part of it. And we should be able to see that all the time. That should be the dashboard we look at every morning as a search team.
Yeah. And since you're doing interventions in the search system, let's maybe move in how we can measure the quality of our interventions. So I assume you need to build up a data set of queries and relevant documents and irrelevant documents to measure it. How do you go about actually building that, and how large especially should that test data set be?
As I said earlier, you can start with as little as 50 queries, and you might measure, say, the first 10 or 20 results and judge whether they're relevant or on a particular scale. And that's a start. And if your 50 queries are sampled across your query sets, not just the most popular queries, but also some further down, basically search queries, they follow a power curve. You get the lows of the most popular ones, and then it goes down to a very long tail. But you need to sample through that, and there are various ways of doing that. Just get your first 50. Now, how many you actually test regularly is down to how many you can cope with. Should it be 50 or 500? And it's down to the size of your business and how important you judge this problem. But once you have those, you can then figure out what are the relevant results with some kind of human judgment or maybe with a bit of AI help. And that gives you your first test set. You're not going to have that test set forever, but it's a starting point. You'll also maybe want to adjust it, add new things as new things turn up. So after a certain time period, revise it. But it also gives you some regression because you want to make sure if you make a fix, you don't break something. So constantly testing this test set and making sure that your sudden new idea for changing the search configuration hasn't broken lots of old queries. That can be part of your regression test cycle. It could be something you run automatically every time you do a release, for example. So it's a vital tool for checking that you haven't just broken search accidentally.
Yeah. And do you add metadata to the different queries as well? So basically add something like a query type, so you actually can measure the performance across the different query types which pop up most often?
Yes, you can do that. And again, you can subdivide the queries. We have a concept of the information need. Well, what information need is this query answering? Again, I want to know where the office is in London. I want to buy some red shoes. I want to know what jobs there are in Poland for Java developers. Everyone's got an information need. And if you can connect a query to that, gives you a lot of insight into why the user is doing that search and how we can solve that problem and what should the relevant results look like. Query classification, breaking things down, trying to understand what the user is trying to do, which can be a bit hard when they've just given you 2 words. That gives you a much better way to try and think about how we're going to solve this problem. In some cases, it may not be with a set of search results. Now, where's the office in London? I just wanted you to show me where the contact page is with the address of the office in London. I want a single result. Or maybe just want to redirect the browser to that place. It's not always a case of just a set of links being the best result. And increasingly now, where we're moving into AI systems, actually, maybe I just want an answer. I don't want a list of links at all.
Yeah. And the scoring. What are the different types of metrics you set up? Especially like more of the common one is, I think, precision and recall, we don't really have to cover, but more of the uncommon ones and also like the business relevant ones. Like, how do you go about like setting up custom relevancy functions?
So there are lots of ways of measuring, getting a single number for how good search is, a search metric. Some of the common ones we see, for example, NDCG, normalized discounted cumulative gain. We have MAP, mean average precision. These are all what we call search nerd metrics. And they do things like they help account for things like position bias. So people generally prefer the results at the top of the list, even if they're not relevant. So people will click on the first few results. People will think those are better somehow because they're top of the pile, that whole thing. So there are various things here to help us cope with that. Now, these numbers are great and search nerds love them, and we can think about the theory. And they give you a number to say how good is search. But this is only from, again, the search nerd perspective. What the business is doing is slightly different. The business is selling things, say, or delivering information in a certain way, or trying to retain customers, whatever the reason for search is. So what we also need is some kind of KPI. We need some kind of business number that we're trying to optimize towards. And these two things may not have many obvious connections. But if we manage to come up with a KPI at the business level that the search team can work towards, that gives us an ambition. So, for example, we want to maybe show more results that would make us more money as a business in some way. Now, we can't optimize completely for that because otherwise our users are going to be very unhappy. because all you're showing me is things that are really expensive. I just want to buy some cheap shoes. Why do I always see the most expensive shoes at the top? So there's a balance between the business objectives and the user's objectives here to be taken. We can't go all the way one way, all the way the other. So some search teams measure their search node metrics, and that keeps them pretty sure that their search engine is working in the right way technically. But they've also got to take account of the business metrics, the KPIs, the numbers we're really there to solve. And this can almost act as a kind of contract. So my business stakeholders want the search team to do something, and let's work out what that actually means. And we agree on some kind of metric. We want to get more people clicking on these particular things. We want to raise the average order value down that we know is attributed to search. That's quite a good one. So we know that people buy a certain amount of things or have a certain order value after doing a search. Let's try and raise that. Let's try and make search power more business. That might be one you pick. But this is a discussion you have to have with your business stakeholders. And that then gives them an idea how well you're performing as a search team. And it gives the search team something to aspire to. So that kind of almost informal contract is a great way to connect the two sides. The sad fact is very often search teams don't really know what the business is for, what the business is trying to do. They don't have a detailed understanding of the business strategy. And the business stakeholders don't really know what the search team are doing. They don't really understand how the search engine works. And a lot of my job is trying to connect those two sides to get people talking and communicating so they can both drive forward together. A lot of it is just education, it's process, it's numbers. It's a way for everyone to come together and say, this is what our joint challenge is.
I think especially the relation to other external factors makes search so interesting. How do you bring them into the search engine? Especially stuff like what we talked about, like the dollar value of an item, or also the recency or the overall popularity of an item as well. How do they come together with the search matches, like the keyword, term, TF-IDF, or semantic similarity score? How do you combine all of those?
So that's a really interesting question. If we were just in the lab building a search engine, our TF-IDF or our statistics that underpin all some modern search engines, really, that's all we care about. Does this word match? Is this word a popular word? Therefore, should it affect the statistics? That's fine. Now, the sad truth is, once you've got that basic algorithm, you then have to mess with it, and everyone does. So everyone modifies their basic search algorithm in some way for their business objectives. So recency is a really good example. If you're doing a news search, for example, today's news is probably more important than yesterday's news. But how much more important? And is that the only factor? And I've had conversations with people in the news business who said, actually, recency is the most important thing. Relevance, keyword matching, not so important. And if you go all the way with recency, you end up with whatever you search for, you get today's news stories, which isn't great, obviously. If you go all the way to relevance, then you don't see today's news stories because they're somewhere in the hundreds of results. So you need a balance. And you don't really know what that balance is. A similar thing with, let's think about popular items, things that people have clicked on before or bought on before. Now, if we only show popular items, then you get a self-reinforcing behavior and a new item will never show up because it's got no history. So again, there's a balance here. Now, where is that balance? We don't actually know. The only way to find it is by experimentation. And my mental model of a modern search engine is a bit like a mixing desk in a recording studio. Your task is to make things sound nice. And you've got 200 little sliders and faders and volume knobs and twisters and these sort of things. How do you set that to make it sound nice? You use your experience, your intuition, that maybe a bit more bass here because it's this kind of music, fine. But you can't come up with a definitive answer of where those things should be to make the thing sound nice. So you try things out, you experiment. So an experimental methodology is absolutely vital here. Now we have some kind of KPI we're trying to get towards, but we don't quite know how to get there yet. So what we have to do is do repeated experiments, measure, rinse, repeat. We do a search, we get some results, we come up with some numbers telling us how good those results are. Yeah, it's okay. It's only sort of 6.5 out of 10. I know. Let's see what happens if I boost the title of the search results. So matches on the title, we might intuitively think is more important, the title of a news article, for example. Let's try that. Let's make the matches on that title a little more important. Try that, rerun our experiment. Oh, it's gone up to 7.5. Brilliant. Okay, that sounds like a thing. Let's do more match on the title. Let's try 25 match on it. Let's boost the title even more. Oh, hang on. Actual relevance has gone down because not all the titles are, sometimes the matches are in the body text. But we have to keep these experiments going and repeatedly doing them. And that will give us a better idea of how to get to that eventual target and keep our search quality up. Now, you can't do thousands of experiments a minute, and there are some automatic techniques, things like gradient descent, for example, where you can iterate towards a place where these parameters are about right and do it in a more automatic way. There's lots of techniques, but the point is the quicker and the more often you can do these experiments, the better. And if you can do them offline, even better, because you don't want to be doing this with real people. You want to be doing this in A/B tests, which might take 3 weeks to give you some results. You want to do it in your little search lab, trying things out. And then when you find something that's really cool and seems to give some promise, maybe put that onto your online system and try it out in an A/B test. But that rapidity of experiment is absolutely vital because you don't actually know how to balance these different factors to give you your search results in the right way. There are some other techniques you can look at. There's machine learning based techniques such as learning to rank, where you do a search, get 1,000 results, and then reshuffle them using a machine learning model that's trained on some particular objective and using a set of signals. And a signal might be how often someone's clicked on a particular result. And the machine learning algorithm can then learn how to reshuffle the results in the best way. But you need really good data for this. You need a good understanding of your model, a good understanding of your data. And it's not something that search teams get to till a little later, but it can be very effective once you've tried everything else. And in fact, in most situations I see, there's a lot of really simple things you can do to make search better. And most people we talk to are starting from that ground where really they haven't tried anything too clever. Or worse, they've tried a few numbers, a few boosts here and there, through their intuition. They've tried to move some sliders up and down. It's okay, but they've got no real understanding of why. They've just tried stuff and it's made things a bit better and they've left it there. We want to actually do this by experiment. So we've got some actual base to say, we tried this, we tried 6, we tried 7, we tried 8. 8 was a sweet spot. Well, that's where we got to. And we've got a story for why we got to that point.
So to mirror it back a little bit, that's the importance of having a test set. So you have the luxury of only pushing major changes to production that you can then run an A/B test on, which is very costly in terms of iteration speed.
Yes. This is something we talk to a lot of people about, the idea of having an offline search lab, somewhere you can try lots of experiments based on data you've collected through ratings or clicks. And that's where you do lots of experiments all the time. And then the best experiments, the ones that really show promise, then bubble up to the online situation where we can test in front of real people. The trouble with online, of course, is it takes a long time to collect the data. Also, a cohort of your users are going to get a worse experience because by definition, an A/B test, A or B is worse, and it can harm your business. So you don't want to try some crazy idea out on an A/B test. You want to be pretty sure it's a good idea, pretty sure it's going to improve things. Yeah, we like to try the crazy ideas offline with some offline data, a test set, and some idea of relevance. And then eventually, once we're confident, we can bubble that up to online.
And you just mentioned there are always a few simple levers people can pull. What are the first few simple levers that you would recommend like search engineers to try?
A few good examples. Phrase search is quite a good one. Is there a way where, we're going to match more words in the query, closer together? That can sometimes help. Simple boosting, boosting titles is often quite a good idea. Most modern search engines have a slew of different features you can try. Having a look at the fields and the metadata as well. Where is this data distributed across fields? If you're searching for a particular quality, if I'm searching for red, there should be a field somewhere in my data that's the color of the item. I shouldn't need to look for that red word somewhere in a description somewhere. We should have a field that says red. Should we have a color field for something if we're selling lots of colored items? How's that working? Is that coming through from my data correctly? What about crimson? What about rude? Varieties people might use. Is that consistent in my data? Very often we see data sets that can be incredibly complex with hundreds of different fields. Sometimes a lot of these fields have not really much information in them at all, or they're only used for one particular kind of item. And so doing some analysis of the source data is important to figure out what are the fields we should hit. A common pattern is people to take the source data and dump it all into the search engine. We're going to need it one day. Let's just dump it all in there. But actually, you don't need to match on everything. You just need some of that metadata generally, and you need to do some analysis to figure out which of it is important for searching. Which of it is the sort of thing people are going to query for. When it comes down to it, search is a problem of language. You use a particular language when you query, and my data has another kind of language, and the two may not match up. What I call something in my source data isn't necessarily what you call something in your query. So we're trying to connect those two things together. So there's other strategies here, synonyms, calling two things the same thing, two different words. There's spelling mistakes. So people mistype things, and most search engines have got built-in ways to correct some of these simple spelling mistakes. You can also fix that with synonyms. We've got strategies such as using query rewriting. This is a very powerful thing. So you type in cheap iPhone, and the results that come back are iPhone accessories. And that's not what you wanted. You wanted the actual iPhone. Why show me accessories? So we might need to push down those accessories down the list. And then you said cheap iPhone. Now, cheap doesn't really help in this case. All the iPhones we sell, they are the price they are. And cheap is now matching somewhere else and polluting our results. So we're going to get rid of that word cheap. So I'm basically interfering in the query you've put in, but I'm doing it for a good reason, to improve my business or to serve you better. All these strategies need to be assessed based on what are the actual problems we've seen, how do we prioritize them against the business objectives, and what data do we have to measure how good or bad this is. But yes, there's intuition as search experts, but we're also trying to be data-driven. We're not just going to make stuff up. We're not going to go into mysterious tweaks for you and that you don't necessarily understand. We want you to understand why we're doing it, and so you can support this and own it as you go forward.
What do you think is the role of data modeling in search and search databases?
Data modeling, as I've said, is I think looking at the way the source data is structured and how that's going to work for search, that's effectively what we're doing. We're building a model of your data in the search index. We don't need all of it. We need some of it. We might need to collapse some of it, glue some of it together, modify it, translate it, process it. Every search system is different because all the source data is different. The process of indexing, if you start from scratch, does involve a deep understanding of what is the data we're trying to search. Even what shape and type it is. Is it 3D models, or is it geographical information, or is it books? All of these things need different strategies. So we need to think about that from a search perspective. One common thing is, what is the thing that we're trying to return as a search result? Is it a document? Is it an email? Is it a product? Is it a geographical location? Is it a picture? Where is that thing represented in our data? Maybe it comes from 5 different places that have to be glued together in some kind of object before we can index it. But what is the task the user is trying to carry out? If I'm searching for a bit of clip art, for example, I might type in some words, but I want a picture. So how do I connect those two things together? Is there descriptive text? Have these pictures been categorized somehow? Have they been classified? Have they been tagged? Do I have to do some kind of clever translation of images to pictures, or use an AI model, whatever, to create the data I need? But what if people are searching for a picture by dragging another picture onto a box, or taking a photograph with their phone? That's a different methodology. So how can I support that in my data? How do I match those two things together? Again, how you represent something and how I represent something are very different. They may be different in terms of object types. One may be a picture, one may be some text. How do I glue those things together? The data modeling is an essential step, and we do this a lot when we look at greenfield search, but also when we try and maybe repair existing search installation. Have we understood how to represent the source data in the index in a way that supports the query?
Yeah. And when you have set up like all the stuff you need for the evaluation, how do you actually prioritize like different queries, document representations, all the levers you could pull? How do you especially balance like the quick wins you can implement quickly, or more of the long-term implementations and more challenging aspects of improving it?
I think it depends on the context. Sadly, I often see people who are in bad situations because their search is broken. Everyone hates search. We know our search is terrible. We'd never be able to get search working. I hear this all the time. So I think to build support within the business that we are on the right path, quick wins are really important. And luckily, with some intuition and experience, you can often find a few things you can knock off really quickly that will make search better overnight. But you don't want to stop there. This should only be a supporting strategy. You want to say, look, we're now at the beginning of this process. We can do a few things, make things better now, but we are going to need a proper process. So the quick wins help you build support, both at technical, product, and stakeholder level, for building a search improvement process. And that is not just a question of technology, it's a question of people, a question of procedures, a question of making sure people are meeting regularly, even how you're recording search issues. Don't just react to every email complaint you're sent. Maybe use an issue tracker, maybe use a GitHub issues to say, here's a search problem we found. Then your prioritization, how you're going to decide with the support of the business, which are the most important things to do, because you can't fix everything. One of the most egregious examples I saw was a company in the electronics space they were testing something like 20,000 different queries every few weeks. Fantastic. They were testing queries, rating all the results. And they collected all these results in a giant spreadsheet and then emailed it to the solitary search developers. They fix search. And that's a massive anti-pattern. That's saying, which of this do you want me to fix? There's only one person and you've got all of these problems, and search is never finished, but you also need to start at the beginning. So I think quick wins are important, but you also need to put that process in for continuous improvement and realize this is a long road. You want to start fixing some things, build stakeholder support, and just get better at doing search. Search, unfortunately, suffers from the fact that people have historically thought it's a magic black box. It's not as easy as all that. It underpins so much of what we do that we need to have a proper way of dealing with it. Otherwise, we're not going to achieve those business objectives, and everyone's going to still hate search engine 3 years down the line.
Yeah, and I think embeddings aren't doing the search field a service, so that we treat it less as a black box.
I think embeddings are another tool in our toolbox. Keyword matching works really well for a lot of situations, but if you're doing some kind of multimodal search, searching images by text, or you're trying to go slightly beyond those exact matches. So again, if I don't use the same language as you, I've got to rely on synonyms to connect those two things together. But a language model can say this word is close to this word in a vector space. So when I search for this word, maybe I should also search for these words. And that's effectively what's happening with an embedding. It's placing something within a space where we can divine some closeness and therefore some kind of similarity between a query and a result. Now they're expensive to calculate and they've got to be stored in the right way and they add to the footprint of your engine, etc. But they can give us huge benefits. The current question, though, is how do you balance these two things together? Because keyword search is useful for some things, vector search and embeddings are useful for some other things. How do you combine the two? And most of the successful strategies I see are some kind of hybrid. When I type a vague word, I get no exact match. Vector search and embeddings can probably help. When I'm typing a part number, embeddings are no use at all. Vector search is no use at all. That's an exact match problem. So we need to balance these things together. How do we balance them? How much contribution do we get used to from each side? There's another chance for an experiment there. There's another way we can try this out. Embeddings are just another tool in our toolbox.
Why do you think is the recommendation literature so focused on embeddings and the information retrieval literature so focused on more phrase and term search?
Both come from different heritages. I think the recommendation systems, you can build a recommendation system with a search engine. You always have been able to, but more often they're built with some kind of machine learning pipeline. Now, the machine learning people don't necessarily know the history of information retrieval. The information retrieval people don't necessarily know the history of machine learning. So you've got two colliding worlds here. And because of the current excitement around modern, language models and AI, ML is in the ascendant. So everyone's saying we can use these things to improve search. People even said, oh, search engines will go away. We won't need search engines anymore. We'll just need a big model. It'll do everything for us. That's obviously nonsense. It's slightly over optimistic. The interesting thing I'm finding is as we're building these AI powered search engines, people are rediscovering all the history of information retrieval. There's decades of useful information there. You can't just do it with one and you can't just do it with the other. If you want to build a modern search engine, again, it's going to be a hybrid of these two things. So you've got these colliding worlds. You've got some machine learning people who don't necessarily know about the history of IR and what amazing things you can do with text matching in a really efficient, powerful way. And this is how we can build billion item scale search engines that come back in fractions of a second with relatively simple hardware. On the other side, I think the information retrieval people are a little suspicious of this magic world of AI possibly because it's been so massively oversold and it's been telling them they're not going to be needed anymore. And then they're failing to understand there's some real value here in some of the tasks that we've always struggled with in the search and information retrieval world. For lexical search is fine, but semantic search is very hard. We don't, again, connecting these two different languages. If the keyword didn't match, there's a slightly similar keyword. What do? Create a manual synonym. But actually, a language model could really help. So I think we're seeing the two worlds coming together, and that's really exciting. What it has done is brought new energy to the world of search. But that new energy, venture-funded startups, lots of excitement, lots of excitable DevRel people running about the world telling us that vector search is going to change the world. It's all going to be marvelous. But we also need to remember the history, remember that a lot of these challenges have been solved in other ways. And we need the best of both worlds. We need to put these things together to really solve tomorrow's search challenges. So I think it's just a kind of bit of a clash of cultures. The machine learning people, they write Python. They write pipelines. They like Jupyter notebooks. The old search guys is all indexes and text processing. But we're still facing the same challenges to build information retrieval systems, or information systems, recommendation systems. Again, we just need to bring our two worlds together.
I think that's a perfect note to close it. So if people want to get in touch with you, follow you, get in touch with your company or hire you, where can they do that?
They can always talk to me. I'm Charlie Hull at OpenSource Connections. They can come to some of our events, the Haystack Conference. We're planning Haystack Europe in Berlin, September 30th and October the 1st this year. They can jump on Relevance Slack. We'll provide a link to that, which is a 5,000 plus person strong community of people all talking about search and AI, all the different aspects of that. But yes, we're always very happy to help people build better search teams, build better search engines, and really solve those business problems. So yes, very happy to have a discussion.
I think there are a few very interesting things you can take away here. First of all, like the experimentation driven approach that you really have to play around a lot in your data to get good results out of your search engine. And the second thing is like you have to create test sets which enable you to perform this experimentation. And I think like especially in AI, we often like try to short circuit this process, but in search you don't really get around it. So you first have to spin it up, throw your data in there, run a few search queries to actually see like where it misbehaves and why does it misbehave. And you're like in a continual process of trying out some queries, analyzing the errors, first finding the errors, analyzing the errors, and doing a root cause analysis to find the reasons, adjusting your search engine either on the document side. So basically, you're adding new fields, you're pre-processing the document in a different way, you're indexing, you're adding additional search components, and then you basically re-index whatever happens, make the changes, and then you test again and see whether it made an impact or not. I think one thing I would really love to hear more about is like rapid experimentation with a search engine of like sizable dimensions, because reindexing often takes a lot of time. Um, so the experience part of like an engineer is like a massive advantage. If you already know like what is likely to work, you can save a lot of time. And I think also second is like experiment on a smaller scale. And this like take a representative set of your documents, throw them in a smaller search engine, and try to replicate as much of your system as possible. And basically use that for like more speedy experimentation, especially if you already have an existing search engine, and to really find new additional features which move the mark massively and which are maybe even more experimental. Yeah, I think that's very interesting. So, and this was today's episode with Charlie. I think follow along with him. He has like very interesting opinions, especially also on like this new search era we have at the moment with embeddings. Next week we will be talking with Doug Turnbull from Reddit to go even deeper into like the more traditional parts of information retrieval, and also how we can use LLMs to augment the traditional parts of information retrieval. See you next week.